couple of pentagon constructions. This is a classic pentagon construction that we see in the almagest. Take a circle. If I bisect the radius at some point and I join CB, and then I drop this length down to D, this side here, BD, is going to be the side of a regular pentagon inscribed in the circle. OD here, by the way, also works out to be the side of a regular decagon inscribed in the same circle. And this goes back to Ptolemy, and it is an exact construction. And then Dürer then gives an approximate construction. And again, there's something very interesting about this because this is what we would call a rusty compass construction. The assumption here is that you can only open your compass to one specific width, and the compass is jammed at that particular width, and that's all you can do. Now, there are certain things you can do with that particular construction, and Dürer describes a pentagon construction, and I'll just kind of gloss over this pretty quickly. So we draw a couple of circles with the fixed radius that we have, and based on these circles, we can do certain things like bisect angles, draw perpendiculars, and so on. And Dürer ends up with a pentagon that is equilateral. That is an equilateral pentagon, but it is not actually a regular pentagon. There is a slight difference between the two angles. And again, just by taking a quick look at that from a distance, that's a pretty good, that is a pretty good pentagon that does look reasonably equiangular. And again, it really requires us to take a very close look at, in this particular case, the vertex, to see what the discrepancy is. And there's our discrepancy. And if you don't include the arc of the circle, it's not entirely clear how big that discrepancy is. But there's the arc of the circle there, and note that it's flattened out quite a bit, and even at that magnification, the difference between the exact regular pentagon and this approximate construction that Dürer gives is a very, very small difference between the two. This method appears in the Geometrie Deutsch of Matthias Reutzer, which Dürer seems to have taken some other things out of. But again, one of the interesting things here is that these type of construction problems with exact solutions, I will point out, do also appear in this book of Geometry for the Artisans by Abul Wafa. And in fact, from that book, we have an exact construction of a regular pentagon using a fixed opening compass. Well, so Dürer also talks about tiling patterns. At some point, he got fascinated by the tiling at a particular cathedral. The name escapes me right now. And he started drawing a bunch of tiling patterns and thought these are very interesting. And well, we all know that we can find a regular tiling pattern using squares, triangles, and to some extent octagons if we allow in other shapes. And then Dürer also discusses the possibility of using heptagonal tilings and pentagonal tilings. So here's a pattern that we can begin to form if we use pentagons as our basic tiles, and here's a pattern that we can form if we use heptagons as our basic tiles, and then we have this little keystone piece there in the middle. And it doesn't take too long looking at these to draw that there's some interesting parallels here between what Dürer is drawing and what we see in Islamic art. That could just be coincidence. There's only so many ways you can fit together regular polygons. But in connection with some of the other things, one has to wonder what Dürer's sources on these are. And Dürer comes very close to something very interesting. So Dürer goes into some detail about how we can do a tiling using pentagons. And so Dürer's idea is, well, we can take 5 pentagons and throw them around a single pentagon and form what he refers to as a rosette, and what Stefan referred to as a rosette. And then we can combine these rosettes in other ways, and we can fill in the spaces using various other polygons. And Kepler goes into some details on tilings, doesn't mention Dürer's tilings, but what's interesting is 1974, Roger Penrose begins thinking about this issue of, well, can you tile the plane with shapes besides the traditional ones? And Penrose, among other things, does take inspiration from Kepler. And it's interesting, again, if we view a great artist as being somebody who's ahead of his time, Dürer comes very close in some level to inventing Penrose tiles. He misses because he's not really looking for that. So he misses it, but in the process he discovers something that is equally interesting.